Hi everyone, and welcome to this week's video. Today we're going to be going over 4 more proofs, and to start off, we're going to look at some inference rules. So the first rule that we have is the conjunction introduction rule. Basically, if you have two letters by themselves, two atomic sentences by themselves, you can easily add them together, put a conjunction in between them, and then just cite the references of where you got that from. So you put conjunction I for introduction, and then the two lines that you got that from, so M and N in our case, and then you're good to go. Pretty straightforward, correct? So what if you wanted to just get one letter by itself? You can easily just, if you're given, conjunction, you're given both letters, and you want to get one letter by itself. Well, then you're going to have to eliminate that conjunction, right? And then when you do that, you get A by itself, and then that's just from line M. And same thing, if you want to get B by itself, then you eliminated the conjunction, and then again you reference the line that you got that from. So this is pretty straightforward. The conjunction is symmetrical, so you can eliminate. You can eliminate one and get the other. You can eliminate the other and get the one, and you can do that for either sides. This does not work, however, for the conditional elimination. You can't just eliminate, A, and you can't just get rid of. So let's take a look at it. Okay, so say you're given A arrow B, right, in one of the premises, and then you're also given A by itself as also one of the premises. Then you can easily get B by just eliminating it and citing the two lines that you got that from. It's not just one line, because you had to get A as well in line N in order to get B. But I can't go and say, okay, say you had B in the premise, right? You can't get A that way. You can't say, okay, conditional elimination, MN, and you're good to go. No, it's not symmetrical. It doesn't work just like the conjunction. It's a conditional because it's an if-then. If you have this, then you get that. You can't get the end without getting the beginning, kind of thing. So so that's why you can't do it backward. You can't say, okay, I have the end, let me assume the beginning, kind of thing. No, that's not, the conditional isn't working in the opposite direction. It's only working in one direction. So just keep an open eye out for that. Make sure that you have the beginning, right? The if part of the conditional, and then you can get the end part of the conditional. All right, so then when we go to introduce the conditional, how is that going to look? So basically you're going to have to do a subproof within that. And what I mean by a subproof is that you're already given, this is pretty much that line, that bar is your proof, right? That's your original proof that you started off with. But within that proof, you're going to do another proof, and you're going to start a second bar and assume the first part of your conditional that you want. So say you want at the end, right? You're always thinking about what you're trying to do, right? So say you want A arrow B. Well, in order to do that, in order to get A arrow B, in order to introduce that conditional, right, you have to have A at the beginning of the subproof and end it with B. B doesn't have to be straight after A. Right? It takes steps to get to B, right? That's why I put the 2 dots, and that's why it's in their book and in the lecture notes, right? It could take multiple steps to finally get to B, but the idea is that you've got A at the beginning, you get B at the end, then you're like, okay, well, it works. I've got A. If A, then B. Well, that's the definition of the conditional, and so I can easily combine A and B, and then the way to cite that is a little bit different. Again, it's the same as conditional. You always put the connective at the beginning, and then introduction or elimination. In our case, it's introduction. And so it's not I comma J, it's I through J. And why is that? Again, because it took some steps for you to get to that point, to get to J, right? You didn't just jump from A to B. Sometimes it could take some steps. So you have to show that through the reference that you did that. This is different from before, where it's just like M comma N, right? It's just these two, it's nothing in between. But in our case, since we needed to use a subproof, we need everything in between and inside that subproof. Make sense? I hope so. Okay, so what about the biconditional introduction? So similarly to the conditional, you're gonna also have subproofs within it, right? You're gonna have, so what's different with the biconditional is that it goes both directions. So like I said, with the conditional, you only have A arrow B, right? You only have one direction if those are the letters that you're using. With the biconditional, it's both directions, right? It's A arrow B and B arrow A. And that's why you're able to get both directions, but you need two subproofs for that, right? You need to show that if I assume A, I'm able to get B, and you need to show that if I assume B, I'm also able to get A. And then when you finally are able to show that, then you can combine A biconditional B. And again, just like we've been doing, it's the connective at the beginning, biconditional introduction in our case, because we're putting it there. And then it's just like the conditional, it's everything in between that subproof. So I through J, right? And then comma, K through L, everything within that subproof. So why did I put a comma there? Why couldn't I just say I through L, right? Couldn't I just, it's right there. Well, sometimes there might be other things that are in between the two subproofs. So you don't want that getting in between. Just to stay safe, just that subproof, that other subproof, and you're done, right? Comma. So everything in between that one subproof, everything in between that other subproof, combine, and you're good to go, right? All right. Last one, the biconditional elimination. Just like the conditional, you need to have one of the parts, one of the halves of the statement within the premise in order to get the other side, right? So if I'm given, if I want to take away the biconditional and I want to get B, I have to have A in order to do that, in order to eliminate the biconditional. And again, I referenced the two lines that I got that from. Same thing, since the biconditional is symmetrical in this case, I'm able to get B. If I have B, I'm able to also get A because it works in both directions. And then I just put a biconditional elimination, and same thing, cite the two lines that I was given. Okay, so let's take a look at some practice problems to really, really see how we're applying these rules, how we're using them, and to get you guys a better picture so you're ready for your homework next week. Okay, so we're starting off with a problem, pretty straightforward. It's basically assume this, right? Like assume this premise. So this is this is your premise. In this case, it's just one premise, and prove this conclusion, right? Show me how we can get there. So you start off with your bar, and this line here is just to show where the premises end. And in our case, it's only just one premise, so it's going to end right after writing that line. And I just number it, just number one, and you go down to however numbers you need. Okay, so before we do that, so we have to look at what we have and what we're trying to do. So these are like two sides of the puzzle, right? If you get stuck, always think about this. I have a puzzle over here that I'm trying to make into a new puzzle, or I have like one piece of Legos, right, that I'm trying to make into a different piece. So what's the first thing that I need to do, in this case at least, in order to get, our conclusion? Well, I can't really do much. I can't add anything, right? I need to start breaking things apart. Okay, well, how do I break things apart? What do I start with? Well, I was thinking about this. I think the best analogy to use is like, say you've got a big piece of Legos and it's like some kind of box or something that you have other Legos inside, but you have the outermost layer with a bunch of Legos stacked on top of each other, right? It's a cube. You can't start with, say you want to break this piece apart. What's the first thing, the obvious thing that you need to do? You need to start taking out the outermost layer, right? Whatever Legos it took for you to build that, start taking it apart from the outside until you can finally get to the inside and start taking that apart. Well, that's the same idea here. In order to break something down, you need to start with the outermost layer and then get into the innermost layer. So we start off with the main connective, because that's the outermost layer, and then we break it apart from there. So I can break apart A, right? So I'm eliminating the conditional, I always mess up this, the conjunction in line one, right? And then I can also eliminate, all right, I can get one side, I can also get the other side, right? B and C, right? And that's again eliminating it from number one. Okay, well, what else could I eliminate? What else can I take apart? So I've taken apart the two biggest pieces. Now I can take apart the smaller pieces. And again, I'm not just doing this haphazardly. I'm looking at where I'm trying to be, right? I'm trying to get A and B together in a parenthesis, and then outermost C is the outermost parenthesis. Instead of B and C are the innermost, and then A is the outermost, I'm switching that order pretty much. So I need to take everything apart in order to really build it together the way I want it to build it. Okay, so then easily I can take apart B and C, so I get B, and then I eliminate and elimination, and that's from line 3. Again, you always have to cite that. You will lose points if you do not make these citations. Okay, and then again, I can eliminate the conjunction, and I get C by itself. Okay, so now I've got all my pieces together. Now I start to look at what I'm trying to do. Again, this is my proof. This is what I'm trying to get to. This is my goal. So I have A and B. So I want A and B together as my innermost. So again, now that you've broken apart the biggest pieces and you've broken it down to smaller pieces, how do you build stuff? You've got to start with the smallest pieces first. You put them together, you start with your foundation, and then you build on top of that and you get bigger and bigger. So here, what are the innermost pieces in our proof? It's A and B. So let's see. Do we have A and B? Absolutely. We've got them in line 2 and we got it in line 4. And according to our conjunction rule, you can always go back and check that out. You have, if you've got them by themselves, then you can easily put them together through a conjunction introduction. That's what we have here. And you always put the reference. So you put the connective first, introduction, and then the 2 reference lines. So 2 and 4 in our case, because that's where we got them from. And then we're good. Okay, so then what is our final step? Our final layer that we need to add is C, and we can easily do that. We got C, we've got our bigger building block now, and we can easily do that by combining the C, and then we add that in from line 5, C, and line 6, where we got A and B. Pretty straightforward, right? I hope so. Let's take a look at another problem. So say I give you assume P arrow Q and Q arrow R and prove P arrow R. So you know the drill. You've got to start with your bar, and then you've put that line underneath after your premises. So that's what I did in this case. And we're trying to get to P arrow R. So you start thinking about what you can do with the pieces that you're given to get to the goal. So start off with thinking about what can you do with what you have. Okay, so I've got P arrow Q and Q arrow R. Can I just do this? So I've got P, okay? So from our conditional, then when I have P, then I could just get Q, and then that's eliminated from line 1. Oh, and I got Q right here in line 2, I can just grab R, and bam, and I'm good to go, and I've got P arrow Q, and I'm done. Is that right? Wrong. No, it's not right. You're on the right track, but you can't do that. This is the biggest mistake I always used to do. I would just right away assume I would just write it in, like P, for example. I would just write that in, and I would go on to Q, and then keep going from there, and I would always miss it. I would always lose points for that. You can't just do that. So let's start again. You have to start with a subproof. Okay, so we're on the right track by picking out P, but you can't just write it down right away. You have to start with a subproof. You have to assume it. Assume P is by itself, because it's not given to you by itself. If P was one of the premises, then obviously I can just easily get Q and I'm good to go, and I'm done with the problem. But since P is not by itself, I can't just write it in. Right? It's not like a conjunction where I just break it apart and I'm good. No, I have to assume it in a subproof. So this is where we start off. So we've got P, I assume P by itself. And I can do that. That's part of the definition of the of a conditional, right? You've got if this is the case, then this is the case. And you show that in the subproof by doing a subproof where you assume that you've got P. So I've got P, let's assume it. Then from there, I can eliminate the conditional because I've got the if part, and I can get the conclusion, and I get Q. And I'm good. And then from there, now that I've gotten Q from eliminating line number 1, then I can get R, right? Makes sense, right? Same thing that I did from number one in elimination one. I can also eliminate the conditional in line two because I've got the first part of it. I've got the if statement and I can get the end statement. And then from there, what am I trying to do? So let's look back at our proof. We've got P arrow R, right? This is the thing that we're trying to prove. And this is why I started with P, because that's where I'm trying to get to. And I got the end part is R, and that's our definition for how to introduce a conditional. You've got to have the beginning part and then the end part there, like at the beginning of a subproof, the first part and the last part, in order for you to put it together in a conditional. And in our case, it's P arrow R, and I used everything in line 3. So it's not just line 3 and line 5, no, it's line 3 through 5 that I get my answer. Okay, that's how I was able, so through this entire subproof, I was able to get P arrow R, right? And it's not just 3 and 5. Pretty straightforward. I hope this is helpful. These are one of the easier problems that I'm getting you guys just to really introduce you to these ideas. You're gonna get some harder problems, but don't worry about it. I've got a worksheet for you guys where you can really practice those, and come to session next week where we can really practice these. So just some key points to remember. Again, don't wait to the last minute to really practice these problems because they are going to get harder and it's going to take more time to do. And so, so more practice now is going to equal less practice, less time on your homework when you're going to do it. You know, don't wait till Friday morning where you've got like 4 hours of, you know, of work to do that you need to figure out. If you've been already doing the problems, it should take you on the homework like no more than an hour or 2 hours. Okay, so, and to get these problems, I really highly recommend that you do the worksheet that I send you. Again, it's not mandatory, but it's highly recommended just so you can really see the practice problems and really have something in front of you that you can work off of. And come to session next week if you need help. I will be available on my regular session times, so be sure to take advantage of that time. And again, do not wait till the last minute. Good luck, everybody. I wish you good luck on your homework and your final coming up very soon. And have a great weekend.